So welcome to 12.2 part 2. We're talking about interpreting tables, which are really useful in probability and statistics. So a lot of tables are given like this, and it's ways to take raw data and use them to your advantage, especially in different experiments. So a quality control inspector checks for defective parts. A table shows the results of the inspector's work. So there is a chance you see that something that a few of them that were defective did pass. I mean, it is a person, they are fallible. And then there's a couple that weren't defective and were fine that failed. So find the probability that a defective part passes, and B, the probability of a non-defective part fails. So A, the probability that a defective part passes. Well, there's 3. That happened 3 times. But 3 out of how many? Well, 453 passed. 47 failed, 39 were defective, 461 were non-defective. So if you total the columns or the rows, if you add these together, you're going to get 500. If you add these together, you're going to get 500. So there are 500 parts in total. So what's the chance that a defective part passes? It'd be 3 out of 500. And B, the probability that a non-defective failed. That would be 11 out of 500. Now, let's take that a step further. What's the probability that the inspector makes a mistake? Well, that means that it's defective and passes, or it's non-defective and fails. So either of those happening would count as a mistake. That's 14 out of 500. 0.028, which is also 2.8%. So there's a very small margin of error, which is pretty good. This is the type of things that companies do look for when they're trying to limit production value, they're trying to limit human error or even machine error. So let's work with a table for hair color and eye color. So a table shows hair and eye color. What is the probability that someone chosen at random has green eyes, blonde hair and blue eyes, blue or brown eyes? So let's fill in this table. So the way we can read this table, so there's out of 100 people, 27 of them had brown eyes and brown hair. I have green eyes and red hair, so I would fall in this category. So how many students have brown hair in total? 27, 21, 4, so 52 of these 100 people have brown hair. Blonde hair, 7 plus 20 plus 14. And red hair, only 7 people have red hair. These should add up to 100. They do. Now working our way across, brown eyes. There are 34 people with brown eyes. None of them have red hair. Blue eyes. There are 43 with blue eyes and 23 with green eyes. So it all depends on where to look at the table. What is the probability someone chosen at random has green eyes? So all we need to look at is that green eyes column. So there's 23 out of 100, or 23%. Blonde hair and blue eyes. Instead of multiplying like we've had to do before, you take probability of blonde hair times the probability of blue eyes. A table can let you kind of zoom right in. So blonde hair is this column, and which one of them are blue eyes? 20. Has blue eyes or brown eyes? So that lets you look at these columns for eye color. Well, 34 out of the 100 have brown eyes. 43 out of the 100 have blue eyes. So there's a 77% chance they have blue or brown eyes. So tables can be helpful in making these, figuring these out a little bit quicker. So a student has red hair. What is the probability they'll have green eyes? So this is the idea that with the given, they have green eyes, given that they have red hair. I know they have red hair. I want to know the probability of green eyes. Well, that they have red hair is given. How many is that? It's 7. And how many of those are green? 5. So there's a 71.4% chance. So it's pretty high. Once the chance that they have green eyes in general is just 23%. But once you say that it's given that they have red hair, that percentage changes. And lastly, if a student is chosen at random, what is the most probable combination of hair and eye color? The least probable is red hair and brown eyes. That's it's impossible for that to happen. So which of these is the most common? That would be brown hair and brown eyes. And there's a 27% chance that the person chosen at random falls into that category. All right, so hopefully these tables and examples were helpful, and now please do your 12.2 homework.